Hey everybody, welcome back to Business Analytics Advanced Programming. Ever since the outbreak of the COVID-19 pandemic, I know that things have not been very good. We have to work from home. Our daily routines have been severely disrupted. Things have been hard. It's hard to understand that. It's hard to concentrate. It's hard to remain positive at a time where everything goes downturn and everything is a turmoil. You can't do things that you normally would do to relax, to refresh your body and your minds. You can't do the normal recreations besides a study, and now everything seems to be study, or that binge watch. You might, some people may do binge watch and never. It's not easy to stop, as much as you do, I myself have been affected by this change of routines. Whenever routines are changed, it's hard. But I know that human races are strong. I know you and me are strong because we are UH people. We can do this, and it's been almost a month by now that we have experienced the interruption, and while it took probably 1, 2, or 3 weeks to settle down, to think through, and to change the routine. Now things have resettled down, and things have gradually improved. I know this is my situation. My work productivity have improved slowly in the past few weeks, and I hope this is what that has happened to you. I hope that things are slowly getting better as we, are looking for possibly one more month of staying at home and work from home. I have been severely missing you guys. I would like to see you. I would like to talk to you. I would like to get your feedback about any questions or confusions. I would like to provide any clarifications that I can, but it's hard. I know that when asking a question, if it's a complicated question, it's even hard to start in an email. So definitely understand it's not easy, but I know you are strong. We're strong. Let's be positive. We can do this all together. I would like your feedback. I would like your questions more than anything else. Whenever you have a question, let me know. Email me or set up a Zoom or a Skype meeting. We can do this, and believe it or not, sometimes this is even better for troubleshooting on hands-on problems, because I can see your screen. You don't have to move your laptop to my office. In traditional setting, one would not go as far as to schedule a video session just because you can walk into the office. But moving, carrying a laptop and pop in the office is not as easy because there's traffic and there's time conflicts. But now we have a lot of flexibility here, and we can schedule a meeting on the fly. We can schedule a meeting, it doesn't have to be a week ahead. And when I can see your screen, I can tell you what can be improved. It's time saving, and it's more productive and efficient, especially for the hands-on problems that we face, and that you are learning in this course. So I'm very cherishing this opportunity So let me know if you have any questions. Let me know. Don't hesitate. The focus of this video is, of course, Hackshop 5, and which usually would be in class, but we have to convert it to take-home assignment. But that's fine. You can do this, and this allows even more time for you to complete and to absorb what is asked for in this work. And I hope your quality, you will maintain your work quality. So in this video, I will briefly talk about what is this Hackshop about, and in talking about this Hackshop, I will briefly review modules of the recent weeks, including module 6, 7, and 8, and I will quickly preview about module 9 and how module 9 is different from the recent modules that you have learned. And lastly, I will briefly go through what this Hackshop is about and talk about a few important things. Okay. So as you can see here on the screen, I have opened the Hackshop 5 Jupyter notebook. So all the slides, as well as the questions and the contexts and the background information about this Hackshop is in this notebook. So you only need this notebook to complete this Hackshop. And also there are some conceptual questions here, but all the conceptual questions can be answered also in this Jupyter notebook by using the markdown cell. If you don't want to bother using the markdown cell, you can convert a cell into a which is called the plain cell type, and simply record your answer there. You won't change the format. Okay, there you go. Before I forget, for this Hackshop, you also need to download a dataset, a CSV format dataset, which will be used in the middle of this Hackshop. I'll talk about it when we get there. Okay, so you can see that on screen I have launched the Rise slideshow mode of Jupyter Notebook, and this is the first slideshow. A brief review of Module 6. Module 6 is mostly about hypothesis testing, and when hypothesis testing is talked about, mostly the tool or the environment that hypothesis testing is talked about is usually in regression model or linear regression model, and this is what Module 6 did. It talked about the reasons for and the value of hypothesis testing, the procedures of hypothesis testing, different kinds of hypothesis testing involved in the regression models, including the F-test and the T-test. Both the two tests are used for slightly different purposes. And how to extract, how to generate the summary reports of the regression model, and how to get the specific parameters reports from the model fit results object. So that is Module 6. I hope you enjoyed learning Module 6. Now, Module 7. In Module 7, the key points are overfitting of supervised machine learning or supervised data mining models, and cross-validation as a defense mechanism to avoid selecting overfitting. Now, there might be a misconception here that I would like to talk about. Overfitting happens often, which means overfitting happens quite easily. This is by the nature of the machine learning or data mining models. The models are built to be able to absorb the variations and associations between target variable and input variables or features inside the data set. That is the nature of the models. And by this nature, if you allow the model to be trained over and over and over continuously, before long, the model is able to almost memorize the data set, which means to be able to account for every single associations or relationships possible in multiple dimensions between the input and the target variables. Now, such a model is liable to become overfitting. So that's why I said overfitting is easy to happen. Overfitting happens often. It doesn't mean that overfitting is not recognizable. It doesn't mean overfitting is not treatable. It simply means, as a phenomenon, overfitting is natural to data mining supervised methods. And cross-validation is a defense mechanism. I hope by this point you are very clear about why cross-validation is able to allow you to recognize and avoid selecting an overfitted model, and how does cross-validation works, both conceptually and on the programming side. And in module 7, I brought in another type of task, which is classification, and compare side by side between classification tasks and estimation tasks. And this is an important point because in module 7, as well as module 8 and 9 and all the way to 10, when you practice using all these models in the same project, you will start to see that the most of the models are capable of doing both of these tasks, but with important tweaks in terms of how does the model handles the type of target variable under each task, whether or not it's classification or estimation. And in module 7, the second part of module 7, it talked about legislative regression and how is it different from linear regression, when it comes to classification tasks, but how is it also similar to linear regression. And then also demonstrated some hands-on techniques about evaluating to conduct a simple evaluation of model performances under the cross-validation structure. Now here I would like to briefly talk about, to zoom in a little bit about the point I just now was talking about. So I'm gonna write some handwritten notes on the slides on the Microsoft PowerPoint here, and I would need to first to begin the slideshow, the Microsoft PowerPoint slideshow, begin the slideshow. And so, and let me change the color of, let's see, let me use a black pen. Okay, so now you have learned what is classification tasks. And for machine learning and data mining courses or subjects, classification problems are typically the most classic and most typically used type of problems, because in computer science or in data science, classification might be the most prevalent type of problems that they deal with. However, this might not be the case in business research or in business operations. In businesses, there exist almost equally as many as, or maybe even more, scenarios where the target variable is a natural number or a real number, which then requires the data scientist or the analyst to deal with another type of data mining task, which is the estimation problems. So the two are different, and by now you should be very clear about their differences. And I'm going to talk a little bit more about these by using the models that you have learned in module 7 and 8. And the first model that you learned is regression type of model. And regression is mostly a linear model, even for logistic regression, because of the way that the input variables are included. They are included by means of a linear combination, and it's a cross product of each of the input variables with a corresponding regression coefficient, beta typically. And so regression is a group of models. It's not a single model here. And regression under classification is usually the most classic and simplest form of regression models to deal with classification is the logistic regression. I use reg as a short for regression, but for estimation we typically use multiple regression, or it's called linear regression in general. Also use reg as a short. So in terms of algorithms, logistic regression is appropriate for classification type and for a special type of classification task, which is the binary target. Binary classification problems, and linear regression or multiple regression is fitted for an interval type or continuous type of target variable. So that's regression. Another model that you have learned by far is called k nearest neighbor. So k nearest neighbor, KNN. K nearest neighbor is by far the most intuitive methods, either classification or estimation models of machine learning, because of the way that similarities are defined by means of the distance between the different cases by using the high dimensional input variables space. So k nearest neighbor is normally used as a classifier. So that's why when k nearest neighbor is introduced, it's mostly introduced for solving classification problems. As different from regression, when linear regression is introduced, it's typically introduced to solve estimation type of problems. K nearest neighbor, specifically the classifier, k nearest neighbor classifier, is a classification scheme, and it is not limited to solve binary classification problems. It can solve multi-labeled. Well, hold on. Multi-label target. So it's compatible with solving a classification problem where there are multiple labels, not only binary labels, in the target. However, there's a variant of a k nearest neighbor algorithm that can handle estimation problems, which is typically called k nearest neighbor regressor, which I'm sure you have learned about in k-nearest regressor in module 8. Okay, and just for the notation, k-nearest neighbor is referred to k Okay, so this is what I would like to talk about here. Let me bring up the Jupyter Notebook slideshow here. And so that is Module 7 review. And Module 8, as I talked about, you learned about k-nearest neighbor classifier, but also you learned how to how the k-nearest neighbor regressor is modified from k-nearest neighbor classifier to be able to handle regression type of problems or estimation tasks. A critical question here for k-nearest neighbor models is how to choose k, and it is one of the most puzzling questions when using k-nearest neighbor, and there is no best answer. By far, I'm sure you have been familiar with how to answer this question. The answer to this question is different every case and even every data set. You just have to choose the best k by using a data-driven method. By using the cross-validation mechanism without overfitting the model. You can choose the best k by using the k-fold cross-validation performance results of different k's by using the same set of inputs. So that concludes the review of modules 6, 7, and 8. And going forward, and starting this week, you will learn module 9. In terms of not module 9, it's mostly illustrating a complete life cycle of a data mining, or to be specific, a supervised data mining project, beginning from understanding the business problems, understanding the research problems, and understanding the business context, and then begin by importing the data, conduct exploratory data analysis, prepare the data, preparing the variables specifically for specific modeling, and then choose the appropriate models, build a model, and based on the cross-validation mechanism, evaluate the submodels. Evaluate submodels by using different hyperparameters, and also compare the best model under each model type and select the best of the best models. So in module 9, it illustrates a complete life cycle right until the beginning of the deployment or implementation phase. Module 9 illustrates 5 or mostly 4 hands-on heavy phases in the middle of the project life cycle. So here, most of the things are not strange to you, should not be strange to you, because in the beginning of the course you learned the basics of Python, and then you learned the fundamental skills and concepts about about 3 most critical packages for data science in Python, which is NumPy, Pandas, and Matplotlib. So you can, without much difficulty, you will sail through the importing phase, the exploration, the data manipulation, and data wrangling phases in this module. And then in module 6, 7, 8, you learn how to identify informative attributes or informative variables. You learned several classic models and the different variants of models, and how to choose a model based on the type of problems that you're dealing with. And further data preparation of the data for particular models, including standardization, including applying different weights, custom weights for a specific specific types of models, and imputing missing values. You have learned this in module 7 or 8, but there are a few key new concepts in module 9, and here's why. Those concepts are introduced because in the process of managing a big project, you need certain tools that can streamline the process. In managing a large data mining project, the least thing that you want to have is having objects all over the place. You will impute a variable, and that imputed variable is in one place. Is called one thing, and you transformed some of the variables according to the requirement of one model, and that is in one piece. And you transformed some other parts of the data set for some other type of model, and you keep it there. However, in the end, you will have to evaluate different types of models, and under each model you have to evaluate different versions of the model based on the choice of specific levels on the hyperparameters. You would have to be able to compare you would have to be able to quickly run different types of models and different versions of each type of model very quickly, because the longer this process is, the more discouraging it is to the data scientist, and he or she would then be disincentivized to systematically analyze the data set using different models and be able to choose the best one. So the easier this process, the easier for the analyst, for the data scientist, to be able to find and customize a model that works the best. Because this process is not easy. Data model evaluation phase is not easy. It's everything. It can be all over the place if the process is not well maintained. So in module 9, several new concepts are introduced, and this is mostly on the hands-on side. I'll write about what those are, and to manage the process of several types of manipulations, including imputation. Is data imputation. It deals with missing values, right? This is one type, and standardization is the purpose is to normalize inputs, because certain models are not immune to the different scaling of different variables, such as k-nearest neighbor. It's critical to standardize the variables before feeding the data into k-nearest neighbors, because if you don't do that, the results will be severely biased, will be severely influenced by the scaling of the different variables, and you will end up with a model that is totally useless. These are two most prevalent and most common types of manipulations and preparations. Oh, one more thing. for categorical variables, you need to create flag variables. This is for categorical. Right. And so for each of these three different types of performances for imputation in module 7 or 8, I mostly used the data frames fill and a method. So this is a common common thing here in this course. Up until module 8, including from module 2 or from module 3 to module 7, mostly the data manipulation rely on the pandas package, which is different methods and different functions of data frame, or sometimes arrays, because they are sufficient to understand and to explore the data frames and the arrays. But here, in manipulating and in further preparing the variables for models, it's better to use the next package of the most value in these modules. That is the scikit-learn. Scikit-learn is the name of the package on the programming side. Its full name is scikit-learn, but when you import, you use the sklearn. Sklearn is a very rich and useful library for those kind of operations and methods that are closer to the modeling side. Preparing the data sets for models, and including models, and including post-modeling, diagnostic checks, and including cross-validation mechanism is all come from sklearn. That's why sklearn is so useful. Sklearn is particularly useful because it places more emphasis on the data wrangling and data preparation and model diagnostic side, rather than emphasizing those deep learning, very complex algorithms. So sklearn, if you ask me the difference between sklearn and TensorFlow, Keras, and the difference would be that sklearn is more user-friendly in terms of preparing the data set for modeling and for using several classic models, standard models, but not without flexibility. sklearn do allow you to be flexible in terms of building the models. Okay, so now here in module 9, when imputing the missing values, I would use the imputer tool from sklearn, and you will see that. For standardization, I already used sklearn because that is, even for one variable, that provides a streamlined process. And for creating flag variables, I also use it. This one, in module 7 or 8, I used get dummies, get dummies. The data frame methods get dummies is quick and good, and handles the column labels well, but it's not scalable. It's good for a few columns, but it's not good for a large data set and for a large project. And above all of these reasons, scikit-learn has one more very good utility that I demonstrated how to use it, and I encourage you, or I require you to learn how to use it, because it really scales up the performance of your programming in large data mining projects. This is called the pipelines. And pipelines help you put different operations. This is task 1 in terms of data prep, data pre-process, data pre-process process. You have task 1, you have task 2, you have task 3. However, sometimes you only have to do task 1 and 3 on some of the variables, but task 2 on all of the variables, and you also have task 4 on some other variables that will not need task 1 to 3. For all of these, various customized type of processes for different parts of the data set, it's very difficult to manage these by using various pandas methods, which will lead to piecemeal piecemeal DF data frame all over the place and with different names. It's hard, and then by the end of the day, it's hard to put them all together. But pipelines really solves that problem. You can see how pipeline works in this module 9. In module 9, not Hackshop 5, but in module 9, you will start learning how to use pipelines and how to put things together. Very intuitive. Might require a little bit more time to mentally process what is happening here. So if you do have questions, don't hesitate to let me know. Okay, so this is what I'm going to say about module 9, the new concepts. The biggest thing here is pipelines and how to put it to great use. Okay, by the end of the module 9, you will have a very good high-level understanding of how to put everything together and how to make use of pipelines to declutter your data mining processes and data pre-processing steps, and very quickly in a very few code cells, you can finish all those standard pre-processing steps on the data set and quickly start building models. Alright, so next I'm going to briefly talk about Hackshop 5. Hackshop 5 includes a few conceptual questions just to refresh your minds. Most of these questions are similar to those conceptual questions in homework 4, but a bit more, a bit different questions. But this here it also includes some different questions from homework 4. And after that, you have a small scale project where you will import the data, massage, understand a little bit about the data, fix the problems of the data set, and quickly build 2 models to analyze and evaluate the submodels and pick the best submodel under each model type, and then compare 2 best models and pick the best as the best. So I'm going to quickly scroll through, go through the slides here, and I will bring up a few key points when appropriate. And make sure that you download together with this Jupyter notebook. Make sure you also download the wine data set, and this time I will use the white wine data set. Okay, the data set is not very large. It has thousands of rows, but only fewer than a dozen variables, or just a dozen variables. One of them is the target variable, and there are 11 input variables. All of these variables are numeric, and all of these are of the float type. If there's an ID will be the integer, but ID is not an informative input. All the informative inputs, as well as the target variable, are of interval type, and the target variable will be the human rated quality of the white wine type. So you would build models to predict or to estimate or predict the values of quality, and hopefully your data, your supervised model after training is good at guessing how good of a quality is each line in the data set. So here are a list of variable names. Most of these describe the content, quantity of different type of substance in the wine. All right. There are 6 conceptual questions. You'll answer these questions in the Jupyter notebook. Do not use a Microsoft document, because by now I think you are quite fluent and proficient with using markdown cells for just for basic typing and basic formatting in markdown cells to compose your responses to these questions. Just a quick tip: to separate into 2 paragraphs, you simply keep an empty line between the 2 paragraphs. Don't simply use 1 line break, but use 2 line breaks. Hit enter key twice, then you will leave an empty line between 2 paragraphs, and when the markdown cell run, the empty line will act as a paragraph separator. And see that here this part of the requirement is not relevant. Hold on. This part of the requirement is not relevant. Hackshop file will be due by the end of Monday. Will be due by the end of Monday, not by 12:45 of Monday. Submit to Hackshop 5. Click into the header, the title of Hackshop 5 to be able to submit. For the first conceptual questions, it asks you how to read a fitting graph. This is a fitting graph that shows possible overfitting of various models that with increasing model complexity. And there are in a typical fitting model, there are 2 lines, but there are possibly more lines. The 2 lines should be different colored. And the question asks you to identify which line should be the error performance of the model in the training set, and the other line would be the error performance of the model in the test set. So this question asks you to identify which of these lines is the error performance of the model in the training set, and which one is error performance of the models on the test set. Now, the key to answer this question is to realize or to recognize that as you increase the complexity of the model becomes more powerful and is better able to account for more associations or relationships between the target and input variables in the data set. So and it tend to be accustomed to the training set. So the error performance, and keep in mind this is the error performance, this is not the accuracy performance. So the lower the better. The lower the error, the better is the model. So the error rate performance of the training set should be continuously monotonically going down, whereas the error performance of the models on the test set should initially continue to be better, but at some point it will reverse and start to go up. It will be increasingly bad the higher the higher the error, the worse the model. So the key is to know that the training set error performance should monotonically change, reduce, whereas the error performance of on the test set should initially increase, should it initially improve, but then at some point it will reverse and go bad again. The second question asks you a true or false question, and the question says, in supervised predictive modeling, overfitting happens quite often. And don't be mistaken by quite often. It simply means it's easy to happen. It tends to happen, and it can happen. It doesn't mean that it will happen all the time. It doesn't mean that it doesn't mean that it will ruin the model all the time. It's simply saying that this phenomenon is prone to be happening, and if without good understanding of the phenomenon, the data scientist or data analyst will make mistakes in choosing what they thought is the best model, but not really. Question 4 asks, in a tenfold cross-validation mechanism, how many subsets, how many random subsets will the method create by using the original training set? And don't overthink about this question in terms of how many random subsets. The question is simply asking for how many iterations of random sets. Every time it's creating typically 2 sets or 3 sets, but that's not what the question is asking for. The question is asking for in a tenfold cross validation, how many times does it create random partitions or random subsets by using the original data set? So the answer should be very straightforward. And what question 5 and 6 is asking is just the name, the exact name of the package that you should type, when you use those packet or use those tools, object or function in programming. So it's not asking for the model's name, it's asking for the tool's name. So be specific and know that Python programming is case sensitive and space does ruin things. So be sure to not put space when you shouldn't, and not put underscore when you shouldn't, and be mindful about the case of those tools. Going forward, the hands-on questions should be no problems, I think, for you guys. Based on your homework 4, and there are a few questions that are different from homework 4, but have been included in module 8. So I encourage you to study module 8 well and completely before you attempt this hack shop. In this hack shop, it asks you to build 2 types of models. One is both under cross-validation mechanism. One is to build a regression model. One is to build a regression model because the target variable is interval, so it's a linear. It's a linear regression, a multiple regression. And next, you will build a k-nearest neighbor regressor by using the distance-based weighting mechanism. And then you will compare the submodels under each type, and then conclude with the best of the best models of the 2 types. and we'll conclude this hack shop. All right, so that is that is it. That's hack shop 5. I hope you remain positive. I know that you will all do well in this hack shop, and I hope that you will continue to be positive, continue to do well, and next week and this week you will learn module 9. Next week we'll have another hack shop. I will talk about module 10 and talk about a few final comments about this course. And also, oh yeah, class project is already open. As I said almost a month ago, that because of the interruption, I have opened up the final project. So I hope you will plan to start doing the class project as soon as you can, before time runs out. I know you still have time, but there's much more to handle towards the end of the semester when all your courses are having finals and final projects. If you have any questions, let me know. Don't hesitate, email me. We can also schedule Zoom meetings if needed. I can diagnose any of your hands-on questions. Any clarifications, let me know. Also, I'll try to use the discussion forums. I will create Hackshop 5 discussion forum in Blackboard, making use of those because everybody can see the question and everybody can see my clarifications. It will make it easier for all else. The entire class will benefit from your contribution. So, appreciate that. See you later.